This is KC3. The first row of a theater has 12 seats. Each subsequent row has 4 additional seats than the previous row. Which of the following is an explicit expression that represents the number of seats in a row? Below in my handwriting, you should see the explicit formula for arithmetic sequences. The first thing I'm going to look at in my multiple choice answers are whether or not our symbols match. So I'm looking for plus and minus in that exact order, which eliminates letters C and D. The next thing that I look at is this first term, A with a subscript of 1. That represents the first term of a pattern, an initial term of a sequence. So in this particular problem, we have the first row of a theater has 12 seats. Letter A is our answer. Let's do that again for 22. Each time a score occurs in a new board game, 4 points are added to the score of the scoring player. A player already has 12 points. Write an explicit formula that represents the number of 4 points as an arithmetic sequence. Okay, let's take a look at the symbols again. So plus, then minus, plus, then minus. Perfect. Next, I want to look at the initial term, the first term. In this case, it's the player already having those 12 points. Letter B will be the correct answer. Okay. Which of the following is a solution to a linear function? Okay. The first thing that I recommend you do is look for small numbers and large numbers. The reason being, either they're going to stand out as not working or they'll stand out as working, and you'll see it right away. So let's start with letter A because I see that 9. Recall that points are x comma y. So the 9 is in the x's. So if I had plugged letter A in, what's 3 times 9? Well, that's 27. That's already larger than 24. So letter A is out. The smallest number I see here is in letter C. And again, we have a 0 in the x. So what would we have if we plugged 0 in for x? Whoops. Oh no. Come on, eraser. There we go. Perfect. Thank you, eraser. Well, if we had 3 times 0, we would have 0. Okay, so what are we looking at? We're really looking at 2 times 4, which is 8. No way is 8 equal to 24, so C is out of the question. Okay, let's look at letter B next. There's really no way to explain to you how to see that. It's just faster to eliminate the things you know for sure will tell you whether it works or not, and then we're just left with 2 options. So let's take a look here. If we plugged in letter B, 3 times 4, that's 12. 2 times 6, that's 12. Oh, perfect. That's our answer. That was pretty lucky. It could have been letter D, but we eliminated 2 things right away, so that was pretty nice. Let's continue to the next page. I'm going to zoom in a bit. Hopefully. Uh-oh. Alright, so in number 24, we're looking at a table, or 3 tables, and seeing whether or not they can be used to graph this function. The first thing I like to look at in these problems is the y-intercept. It's the easiest thing to see. A y-intercept occurs when x is 0. Okay, so in letter A, 0, 2. Okay, so that one works. Letter B, luckily, has 0 and a negative 2. That doesn't work. Letter C, 0, 2. It's impossible to have all of the above, clearly, since option B is out. And in general, if all 3 tables are different, they cannot represent the same function. That's just logic right there. Okay. The next thing that I'm going to look at is the slope, the rate of change, and that's the 4. I over highlighted right there. Let's try it again, just the 4, not the x. Close enough. Okay, so what that's telling us is the change in y and the change in x's gives us a ratio of 4. So let's take a look at our two tables. The first one, the x's are going up by 1. The y's are going up by 4. Well, that's great. We got our answer right away. Lucky us. 25. A merchant is selling wind chimes from the booth at a flea market. He rents his space for $150 per day. The profit from each wind chime sold is $10. His goal is to make $3,500 in a 5-day work week. Which equation represents the chimes he needs to sell in a week to meet his goal? Okay, so we're looking for the amount of chimes. Okay, let's see what information we have here. Well, one thing we see here is that he rents space. Renting is not earning money, that's spending money. So there has to be subtraction in there. That gives us that clue. So from that, just from that one word of rent, we can eliminate B and D because they do not have subtraction. Okay, let's continue. Now, the next thing I have here is that he's renting for $150 per day. I do see in letter C that I'm subtracting 150, but I don't know where that 5 is coming from or that 10 just yet. Okay. The profit from each wind chime sold is $10. Okay, so that's the cost of the wind chime. Each wind chime sold is $10. That actually tells us something. The word each implies multiplication. So for each wind chime for $10, we should have a 10 times a C, a variable. And you know what? Letter A and letter C both have that. So let's figure out if we need that 5 on the outside or there's some sort of 750 in there. Okay. His goal is to make 3,500. Okay, well, all of them have a goal of 3,500. That's not very helpful. Okay. In a 5-day work week. Okay, well, that gives us some information. He rents for 150 per day, and then I have another unit of days, 5 days. Well, if he works 150, if he pays $150 a day for 5 days, all I have to do here, is multiply 150 by 5, which happens to be 750. So that's how much this merchant is paying for rent. So we're renting for $750. Your brother has $2,500 saved for a vacation. His plane ticket costs $627. Write an inequality to find out how much he can spend for everything else. Okay, first of all, we need to think, can your brother spend more than $2,500? No, it must be less than $2,500. So let's look for some less than symbols. Less than 2,500. Less than 2,500. Perfect. Oh, well, there's also less than 1873. We'll have to look into that. Letter B is out. Well, that's one option down. Okay. His plane ticket costs $627. So that means he for sure spent that money. Unfortunately for us, letters A, C, and D all have 627 in them. Now let's think about it. When we take 627, do we spend that money from an unknown total? Or do we have an unknown amount to combine it with? Now we know how much that total is, and it's 2,500. So we can't be taking it out, so that you can't be subtraction. So letter D is out there. Okay, so now we have to think about this, letter A or letter C. An unknown amount and $627 should be less than how much money? Well, it should be less than the amount of money that you started off having, which is 2,500. Letter C is our answer. That was a very wordy explanation. I'm going to write down another option. Maybe it will help you. Okay, the unknown amount plus the spent amount should be less than 2,500. Handwriting looks atrocious on here. My apologies. It doesn't get better. It doesn't. Okay. Your math teacher is determining how much to save in order to buy all the class's cookies to celebrate the end of the year. Wow, you guys are lucky. Which of the following variables could represent the dependent variable on the graph? Do we have a graph? We don't, but let's say there was. Let's see what depends on what. Okay, so we have two units here. We have, well, money, how much to save, and cookies. So, what depends on the other? Let's think about this. Does the amount of cookies she buys depend on how much she saves or keep? Well, if we only save like 20 bucks, that's only 20 bucks worth of cookies, and that's all I can give out, and not everyone will get a cookie. That's just not fair. Now, let's think about this. Maybe the amount of money the teacher has to save depends on the amount of students in the graph, in the class. Well, that makes more sense. You can calculate how many cookies to buy depending on the students. So, the cost depends on the students. Suppose a charity is having a family walkathon to raise funds. They think 800 children and 1,000 adults will attend. It will cost $652 to put on the walkathon. They want to raise $5,000. Given the following choices, identify the variables needed to create the equation. Okay, well, let's see what we have. We have the fact that there's 800 children and 1,000 adults. Okay, and then I also see a couple of money numbers. I see 625 and 5,000. So the 625 stands for the cost of the walkathon, and 5,000 stands for how much they want to raise. What I don't see money-wise is how much are we going to charge for the children and the adults, when they attend the walkathon. So let's find that option. Cost of the tickets. We don't have enough information about the money. That's what we'd have to solve for. Suppose you want to graph this line that you see right here. Showing the height of a pile of garbage at a landfill beginning January 1st. H represents the height of the garbage in centimeters. D represents the number of days since January 1st. Since H depends on D, the vertical axis will be the H axis and the horizontal will be the D axis. Given the scale on the horizontal axis, choose an appropriate scale for the vertical axis. Okay. The way I'm going to choose my scale is going to have to do completely with the rate of change. The rate of change is 2. It's 2 over 1. The reason I wrote this as a fraction is if you recall, when we graph, looking at an equation, we'd have to go up 2 to the right 1. Well, we have to do the same thing on this graph. We have to go from point to point, except going to the right 1 is going to kind of suck. If you take a look at the x-axis, it's going by 5s. I'm going to write a 5 down here. Whoops. I don't know the pattern of my y's. I solved this by cross multiplying. And you should probably remember cross multiplication. Does this look familiar? Alright, we have y equals 10. Alright, we're going by 10s. Oh, that's it for KC3. If you have any questions, you know what to do.